Good day, engineers. So, para sa video natin ngayon, ang i-discuss natin is about the doubly reinforced beam. So, we are done with the analysis and design of singly reinforced beam na kung saan yung reinforcement is only on the tension side. But for this video, we will be having a reinforced concrete beam na kung saan meron na tayong reinforcement on both the compression and the tension side, which is known to us as doubly reinforced beam. So, start natin yung discussion by having the singly reinforced beam. So, sabi natin, pwede nating sabihin that a reinforced concrete beam is to be designed or to be analyzed as singly reinforced beam if and only if the raw maximum is greater than or equal to our required steel ratio. So, this is the singly reinforced beam. So, however, if our required steel ratio is greater than the maximum steel ratio, therefore, this one is a doubly reinforced beam. This is for the case of the design. Pero kapag nandun tayo sa analysis, ang tinitignan natin is yung actual steel ratio. So parang ganito lang din. So, raw maximum is greater than or equal to the raw actual. We will have a singly reinforced beam. Then, if the raw actual is greater than the raw maximum, that will be a doubly reinforced beam. So, the raw actual na sinasabi ko is yung raw actual which is the value AS over the BD or the AS actual. Ibig sabihin, kung ano, kapag nasa analysis tayo, kung ano yung nakalagay na reinforcement dun sa beam, that is the AS actual, which is yung number of bars times the area of 1 bar, or 3 times pi over 4 times d squared, or db squared. So, yun yung sinasabi natin na pinagkukunan natin ng steel area actual, and galing dito sa AS actual over BD, makukuha natin si steel ratio actual. So, nandito pa lang tayo syempre sa analysis ng Doubly. So, we have here yung diagram for the stress diagram and strain diagram for the analysis of doubly reinforced beam. So, as you can see, we have here a compression bar on our compression side. Let's say this beam is resisting a positive moment, kaya yung top reinforcement will be known as compression reinforcement or compression bar, and yung nasa baba is a tension reinforcement. So we have here yung compression reinforcement. So ang area niya is A prime S. So A prime S, that is the area of the compression reinforcements or compression reinforcement. Then, yung AS dyan, syempre, yan yung area ng tension reinforcement. So, halos magkaparehas lang yung parts nito or yung mga notations dun sa diagram nung singly. Ang nadagdag lang dito, meron tayong A prime S at yung D prime, which is ito. That D prime is the concrete cover from extreme compression fiber. So para yung CC or yung mismong concrete cover nung beam natin, the difference is that dun siya sinusukat on the compression side. So for this one, syempre, si D prime dyan, it's the same as the concrete cover. So madalas naman ang compression reinforcement natin is just a single layer. Therefore, that D prime corresponds to a value, the concrete clear cover plus the diameter of the stirrups plus the diameter of the bar divided by 2. Yan yung D prime natin, which is yan yung nakita nyo dito. So, yan siya, yung D prime. Then, syempre, yung D pa rin natin dyan, that is the effective depth. Then, we have the base of the beam and we have the height H. So, syempre, lahat ng manggagaling from this analysis, kapag hindi pa siya minumultiply ng reduction factor, will be a nominal moment. So, sa case ng double reinforce, unlike sa singly may makikita kayo isang diagram lang, which is ito. This diagram came from the singly reinforced beam. However, in the case of double reinforced beam, dalawa na silang diagram. Ito at ito. So, ibig sabihin, they are separate diagrams which will cause two different moments na galing din dun sa main beam natin or dun sa original beam. So parang pinaghiwalay yung beam natin. So ibig sabihin kaya tayo nagkaroon ng double reinforced beam kasi meron tayong tinatawag na excess moment. As you can see, itong second diagram na to is an excess moment of the original singly reinforced beam kasi this diagram represents the singly reinforced beam. So ibig sabihin yung naidagdag or yung isa pang diagram is just an excess of what a singly reinforced beam could carry. So, ibig sabihin, the diagram number 2 is an excess moment. So, as you can see, meron tayong dalawang compression and dalawang tension. Then, they have a moment arm sa first diagram. Siyempre, nandun pa rin yung D minus A over 2. And nandun yung D minus D prime for the second diagram. Kasi kaya naging D minus D prime yan kasi this is D. Tapos, babawasan mo nung D prime na nasa taas, which is the concrete cover from the extreme compression fiber. Tapos, tignan natin yung strain diagram niya. Sa strain diagram niya, syempre, from the code, sabi natin, there's the maximum concrete strain which is 0.003. Nandito pa rin yung E sub T natin or it represents also the value of the epsilon S kasi nga single layer beam lang siya. So, meron pa rin tayong epsilon S and epsilon T. Then ngayon, ang nadagdag dito is yung F prime S over ES or the strain for our compression reinforcement. So, as you can see, meron naman tayong distances dyan. Siyempre, mula dito hanggang dito, yun pa rin yung C. Ang nadagdag lang is yung part ng D prime and this will be C minus D prime. So, that will be the parts of the diagram for the double reinforced beam. So now, to further analyze this beam, kunin natin yung diagram from, or the first diagram from this one, which is kamukha siya nung nasa singly reinforced beam. So, we have here yung, syempre, yung 0.85 F prime C, which is the stress dun sa compression. Then, yung depth of compression block A, yung C1, which correspond to the compression force, and the T sub 1, which correspond to the tension or the first tension reinforcement. Or the first tension for the double reinforced beam. So, syempre, coming from this diagram, we can say that we have C sub 1, which is equal to, syempre, rectangular yan. So, buo pa rin yung force niyan. So, kung ilalagay natin siya on a figure, ganito yan. Syempre, 3D diagram. Which corresponds to this one. So, this is 0.85 of F prime C. And this one will be the B. And this height will be A. So, syempre, that still corresponds to 0.85 F prime C A times the B. So, that will be C1. Then, we can have T sub 1, which is equivalent to, syempre, the first still area, AS1, and we assume that this one is yielding, so therefore, we have Fy. So, kasi, we are on the double reinforced beam and we are assuming na nag-yield pa rin yung steel natin. Yung tension reinforcement, kahit naka-double reinforced na siya. So, we stick to that assumption. So, for the moment, coming from this diagram, we will have the first nominal moment, which is equivalent to, it's either that is C1 times 0.85 or C1 times the moment arm, sorry. This is the moment arm, D minus A over 2. So, that will be D minus dA over 2. Or, it can be T sub 1, which is equivalent to, or T1 times D minus A over 2. So, that will be the first nominal moment coming from the first diagram. Now, we proceed to our second diagram. As you can see, meron tayong bars na lang dito. So, yung compression bar and yung part of the tension bar or second part of the tension bar. So, we have here C sub 2. Since it corresponds to the compression bar, it will be coming from this diagram, that is A prime S times Fy, or hindi natin it's either the steel yields or the steel does not yield. So, ibig sabihin, pwede rin siyang A prime S F prime S. So, the F prime S stands for the steel stress for compression. So, yan ngayon yung compression natin for the second diagram. Then, the tension for our second diagram will be T2 is equivalent to the value AS2. So, we assume still that the tension still yields although it is doubly reinforced. So, we have AS2 Fy. Now, for the second nominal moment, so that will be equivalent to C2 times D minus D prime coming from the moment arm of the couple force, or it can be 2T times D minus D prime. So, syempre, It's either of the two yung values nung moment for the second diagram. So now as you can see, coming from this one, para makuha natin yung total moment of the beam, we can have Mn is equivalent to Mn1 plus dMn2. So, ibig sabihin, sa ganyang paraan natin makukuha yung nominal moment of the beam. Of the whole beam. The doubly reinforced beam. So, we can say that second nominal moment is an excess moment from singly. So, isa siyang excess moment kasi nga, ibig sabihin nun, it's part of an additional moment na para makapag-carry ng additional moment yung singly reinforced beam. Kasi sabi ko nga, this part of the first diagram is a singly reinforced beam. And this part is the excess moment for a doubly reinforced beam. Kaya tayo naglalagay ng reinforcement on the compression side is para magkaroon ng excess moment na i-carry yung beam natin sa capacity niya. So, kung kukunin natin from here yung static equation, we can have C is equal to T. Whereas, yung C natin will be C1 plus C2 is equal to T1 plus T2. But as you can see, yung tension 1 natin dyan is only the tension the tension reinforcement. So, ibig sabihin, we can simplify T1 plus T2 as a value T. So, that will be C1 plus C2 is equal to T. So, that means, yung C1 natin dyan is equivalent to 0.85 F prime CAB plus A prime S Fy kung steel yields is equal to AS Fy na lang. Kasi nga, yung T1 natin dyan is AS1 Fy, yung T2 natin is AS2 Fy. And that is corresponding to AS Fy. Kasi sabi din dito, AS is equal to AS1 plus AS2. So, here's the valid condition for our statical equation. Ngayon, all of these values are just based on the assumptions coming from the diagram. Pero, sabi ni code coming from NSCP 2015, kailangan natin i-deduct yung strength na nawala dun sa butas na kinreate nung compression reinforcement natin. As you have remembered from our previous topic, from the concrete crack and uncrack, di ba lagi tayong nagbabawas ng area doon for this one? Kapag binutasan yung konkreto natin. So, pwede naman na ibawas natin siya doon sa area na part. Pero, para mas madali, sabi ni code, ibawas na lang natin siya on the strength of the steel. So, paano mangyayari doon? Ibig sabihin, si C2 mo na dating A'S Fy or that is A'S Fs or F's, ibabawas natin ngayon sa kanya yung strength nung nawalang concrete. So, ibig sabihin, yung C2 natin from the code, so this will be code provision or code. So sabi, yung sito natin is magiging A prime S times Fy minus 0.85 of our F prime C. And also, or that will be equivalent to A prime S times F prime S minus 0.85 of F prime C. Ginagawa natin yung bawas na yun kasi nga hindi naman pwede, allowed naman yun na magbawas tayo sa area from the concrete dito. Pero syempre, kapag binawasan natin ng area yan, pag ito binutasan natin, we will be on the irregular shape beam. So, kapag nandun ka sa irregular shape beam, syempre, yung aim mo dito is hindi mo na gaanong magagamit kasi nga, nagbawas ka na ng area. So, you will be needing the Varignon's theorem para makuha yung centroid kung saan nag-a-act yung C1. Unlike for this one, kapag hinayaan natin siyang rectangle na ganyan, yung C1 natin dito, ang area niya is A over 2 pa rin. Or yung centroid niya is located at A over 2. So, ibig sabihin, wala tayong gaanong babaguhin dito sa diagram na to kung ang susundin natin is yung ginagawa ni code na nagma-minus na lang sa strength ni C2 or yung compression reinforcement kagaya nito. So, from this one, we could say na meron tayong nominal moment 2 na kapag ginamit natin yung compression C2 times D minus D prime, we can have A prime S Fy kapag steel yields times D minus D prime, or kapag steel does not yield, we will have A prime S. So, kalimutan ko siya ibawas. So, this should be Fy minus 0.85 ng F prime C times D minus D prime. Then, yung dito naman na part will be, or that is AS Fy or F prime S minus 0.85 F prime C times D minus D prime. So, yan yung case kapag sa nominal moment ng second diagram natin kukunin. Syempre, yung statical moment or yung statical equation natin na C is equal to T kanina, so, yung C1 plus C2 is equal to T is magiging 0.85 F prime C AB plus, that is A prime S Fy minus 0.85 F prime C is equal to AS Fy. So, yan ngayon yung magiging equation natin kung gagamit tayo ng static equation assuming yung compression reinforcement is nag-yield. So, this is compression steel yields and tension steel yields. So, yan ngayon yung condition natin for our NSEP 2015 kapag ibinabawas na natin yung strength na binutas nung rebar natin dun sa concrete natin. So, that will be all for the concept nung doubly reinforced beam. For our next video, we will be having the steps in analyzing the doubly reinforced beam. So again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.